Hi guys, welcome back. In this episode, what I'm going to do is help you with hopefully a nice piece of DIY repair kit. Today we are going to be making a handy device that some of you may know and some of you may not. It's been around for a lot of years and it's called a dim lamp tester. Now these are all over YouTube, and if you look around you can actually see them. They are used in the early days for current limit testing, and that was in such a way that when you plug something in it didn't blow the fuse and take everything out and that. So what we're going to do is get you guys to grab a drink, something to nibble on, sit back and enjoy the video. Hi everyone, welcome back. Well, have we got something a little bit different for you today? This is a piece of kit that can go into your toolbox or on your workbench. It is a DIY current limiting test device. What it does is that it stops anything that may have a dead short or a very, very low resistance from blowing fuses and tripping the house out or the shed or wherever you may be. So this is the diagram, as you can see, and what we're going to be needing to build this is a power socket, which can be either a bayonet or an Edison screw. We're going to need a lead with a 3-pin plug on the end of it. If you want to set it up so you can use a standard PC style power connector, you'll need the male socket to go into the side of your box. So other than that, we are going to need a light bulb or two, depending on how much you want to current you want to put on this. You can use halogen bulbs, and you can only use filament bulbs. You cannot use LED or the energy saver bulbs. They don't work. So the other thing we're going to need is a single pole on-off switch. Now this can be with a neon in it or not, so you can tell if it's turned on or off. A double pole on-off switch, a plastic case, a power outlet, and this is for your mains out, some wire. This can be wiring from an old lead or an extension lead or something, mains rated wire, and a fuse and a socket. If you get these with the PC inlet that you want to use on it, you can get them also with the fuse built into the base of them. A lot of the stuff does not have to be brand new. You can use second-hand stuff if you want to. Just make sure it's in good condition when you go to use it. It is recommended to put 2 light bulb holders on, and that's just so you can have a low wattage bulb for small stuff, and you can have a secondary bulb which increases the wattage, which therefore gives you a bit more safety with the draw on it for the current. You can do either way. The other thing you can use is you can use the long skinny halogen bulbs, a bit like the work lights and that have, but a lot of them tend to be in the higher wattages, and we're only looking at around about a max of about 140, maybe 160 watts maximum we're going to need. So yeah, anything around that sort of style is all we're looking at needing for now. Hi guys, and you ask yourself why it works. Well, why it works so well is that it is so simple, and there is nothing else really that can replace it. The light bulb works like a variable resistor. When the light is off on the light bulb, it has very low resistance. Now I can show you this. I'll just get the meter, just uncoil it, and I'll turn it on to, we want a very low ohms reading, so I'll put it on to 200 ohms. Now this is a B&C, so it has the 2 pins at the bottom. The Edisons had the single pin at the bottom, and they used the side thread for the second connector. So you can see that. So what I will do is untangle this, and then I'll put one pin on one lead and the other pin on the other lead. As you can see, it's about 54, 55. It changes with the heat, because if my hands warm up, it changes as well. So you can see it's slowly starting to drop down. So, but on average, they're about 52, 53 ohms. So, and they can go up to anywhere up to like about 58 ohms. That's when they're off and they're cold. So, as you can see, it's a very low resistance. So what happens is that once the current starts to flow, through the bulb or bulbs will start to glow and the elements get hotter. This increases the resistance of the element. The brighter the bulb gets, the higher the resistance. If you do the basic VIR or Ohm's law chart, we will be able to work out how this works. It's going to be done under DC because it's easier to explain, but AC works exactly the same. It's the same principle. So basically they are the same. We will do our Ohm's law triangle. And so our Ohm's law triangle, it's V I R. And that's voltage, current, and resistance. So that's what your Ohm's law pyramid looks like. So our bulbs say 70 watts. So therefore we'll work out, so our wattage is 70 watts. So to work out what the resistance is, so the resistance of the bulb is 52 ohms, as we saw earlier when we measured it with the meter. So that's our average, and we'll stick with that. So what is the current flowing through the bulb? Well, that's quite easy, because if you do your Ohm's law, it's going to be the voltage over the resistance. So what we do is then we'll turn around and we'll go, our wattage is divided by our volts, which equals our current. So in working that, then this equals, our bulb is 70 watts divided by the voltage we will have coming in is 240 volts, because we're in New Zealand, so it's 240 volts. So we divide that by 240 volts. So when we do the maths on that, it comes to 0.29 amps, or 290 milliamps. So that's how much current is flowing through the bulb. So what's the maximum resistance of the bulb? Well, the maximum resistance that will go through the bulb, voltage divided by current. And that will give us the resistance. So what does that equal? Well, our voltage is 240 volts divide that by our 0.29 amps, and that gives us our resistance of, the maximum resistance of, 827 ohms. Now, as we saw earlier, when we did the light bulb before, we got about 54, but they're generally set at about 52 ohms. So we'll call it 52 ohms. So that's what our bulb is cold. And so when our bulb is fully heated or on bright, it's going to be at 827 ohms. So as you can see, when the bulb is cold, it has 52 ohms. So when you see the bulb starts to light up, the resistance increases. The current therefore decreases. Because you can, if you have one, you have to take away from the other. And as the bulb lights up, it increases to its maximum, which can be 827 ohms. And in doing this, so the current across the bulb decreases. If the device under test has a fault, like a short, the light bulb will be fully on bright. And the voltage across the device should be next to 0. Okay, you're following me now? So how that works is, so we have an input voltage of 240 volts AC. This is our live, this is our neutral. So we have the voltage coming in through here down to one side of the bulb. Then from the other side of the bulb to the load, and this can be any load that's plugged into it. And then from that load it comes out and it goes through to the return on the neutral. So when we have power on, the resistance of the bulb is low. So the resistance of the bulb will be 52 ohms. So when it's 52 ohms, most of the voltage is going to be over here. So we're going to have 240 volts going through the load. So if the load starts to draw a lot of current, so if the current starts going up, the bulb will start to glow. So the bulb will start actually getting bright. So if there is a short, the bulb is going to go very bright because there's going to be a lot of current being drawn through it. So it's going to be to its maximum, so it might be 70 watts. So that's how bright it's going to go. But if that happens, then the voltage on here, on the load, will drop to 0. Because the bulb is using all the current. So if it's using the current, the voltage here will drop. If the device was drawing, say, 30 watts, then the bulb will equally be drawing about 30 watts. 30 to 40. So if that happens, then the voltage here would be 120 volts. Because they're both dissipating about half the current. And the bulb will actually be dim. So that's what the bulb is doing. It is giving us a visual indication of what is going on while limiting the current. That's why the light bulb is so efficient, because it works as a variable resistor, the way they work. Any power supply that draws power through one of these testers, if it's got a PCF in it or power correction factor circuit in it, you may find that they'll flicker, or they will flicker on and then go out. And that's because it's trying to generate enough power to get it to work. Usually you'll find that if they come on and it goes bright and then goes out, the power supply is good and there's not a short. But if it comes on and stays on dim, that could be the PFC in the power supply. If it comes on and stays bright, you've definitely got a dead short of some sort. So there is an issue with the power supply. That's why I say this is a very, very handy tool. How the circuit works is we have our voltage coming in. We go through a fuse, so it's got to be safe. And then from the fuse, we go to a light bulb. Then from the light bulb, we go to a double pole switch. Now we have a double pole switch in it for a reason. We want to switch on and off the live and the neutral. Because if we only switched one off, we don't know which way round the power point is wired that we're plugging it into, or the extension lead or the power box. We've got no idea if anyone's wired it the right way or the wrong way. So what we're doing is we're actually isolating everything. That's why we put a double pole in here. Now we only need a single pole over the light bulbs, because what we're doing is that when we put this on to test, and if our light bulb comes on and then goes off, we know, that's all good. Some devices will find that this is too much resistance for them. So therefore then you close the switch. So when you close that switch, the power runs directly through and not through the light bulb. And then you'll find your device will work fine. If it came on and went off, the device should actually power on. So this is what I'm saying. It's a very, very nice, basic, easy device to save you. And if you're doing retro gear, checking your power supplies. Rather than blowing something up or smoking or what have you, you can use one of these and you're fine. And why I sort of said 140 to 160 watts, unless you're doing anything that needs a lot of current draw, like old-fashioned TVs or big devices that draw a lot of power, you don't need it. This will work fine for most smaller TVs and monitors and stuff like that. What you can do is, if you have the bayonet bulb, you can have one in, have your small one in, and then what you can do is you have your large one out. And so what you can do is, if you want more current, you can actually put the second one in. So therefore then you'll have the two of them plugged in and the two of them combined together. Fine. But you'll want at least a minimum of 65 to 70 watts if you're only going to have one bulb. Okay? And then what you can do is, if you want something smaller, you can take that one out and put a smaller bulb in. Alright, so that's the basics of it and how it works. So now what we will do is we'll get our bits together and we'll start assembling this. Alright, let's get on with it. Right, now we've gotten back. So here's all the parts I've found. Now these are mainly all second-hand parts. So what we'll do is we'll go through everything we're going to need on the build. So what we're going to need is a box. Now this is an old project box that I picked up. It had some sort of thermal switch thing in it and had some stuff screwing. I've stripped it all apart earlier on. It's got something rattling around. It's a tensioner for a cable. So I've got this box here, and I think this will do about the size we want. It screws together, so I think that's going to be fine. That'll do what we need it to do. So we can always put something over, we can always glue something over the top of this, so we can get away with that. So we've got a box. Now if you're looking for cheap stuff, second-hand stuff, I got a whole pile of these old power boards. A lot of electrical guys that do house wiring and garages and industrial and that, they pull a lot of the stuff out and throw it away. So every now and then I'll cotton on to a couple of those and I'll ask them if I can have them, and I get them because they have the single outputs on them, or they'll have like the light sockets on them and that sort of thing, and they have the circuit breakers and that, but if you want to play around with them, they're all good. They sometimes have ganged power points with switches on them and that, so they're really good. Even if it's like $1 or something like that, you save yourself a lot of money. So that's one place. So that's where I got this power outlet off of, was this one, and it just 2 holes at the back here where it screws down onto the board. So I've got the bolts for that, and it's a 3-pin one, and it's 10 amps, which is more than enough for what we want, and that'll fit on top of here really nice if we need it to. So the other thing we need is a light socket. So I had some of these old angled, these are brand new ones. I'm not sure where I put the covers over the outsides, or you can use an Edison, and this is an Edison one that comes in from underneath, that gets into a place. But probably if you're going to get these, get the newer ones with the mounts on them, so you can actually mount them on. That'll fit anywhere on here, and we can point it in whatever direction we want to point the bulb. So I think that's a good fit. The other thing is this is a second-hand. This is a second-hand power point as well. This is the newer style. They come with these quick release backs off them, so the front comes off and you can get to everything inside it. So a single switch. Now I have this as a single switch. It's a mains one, and it's called a mini light switch. So we have that, or I have a couple of pulls from some old PC power supplies or some other sort of electronic gear. These are 240 120 volt, and these will handle enough of the power we want. So these are just on off switches. The other option we've got is you can use a little neon one if you want. This is a dual pole one, so you can use just one pole if you want to, or if you want to, you can use both poles. It's totally up to you. Another idea I had was that I don't like throwing a lot of stuff away, so I go through and I salvage a lot of bits and pieces when I recycle, and these are out of heaters. Now these are dual neon switches. Now you can get them like that, or you can get them like that, and these are only single pole. But what I thought is, what if you had them for your lights? If you have 2 lights, so you could have one light on, second light on. Now it's a nice little compact switch for doing that, so you can have your low voltage one on and your high voltage one on, whichever way you want to go, and you can actually wire the neons up so they'll come on telling you which one is on. So I mean, that's an idea there. But other than that, so that's switches. The other thing is these are out of PCs as well. This one may have been a PC, it may have been out of something else, but this is a neon one as well, but that's just a double pole switch. So I mean, something like that would work. Or this is a non-lighted one, which is just a normal on-off switch. So something like that. And if you're going to use something like that and you want a light, use a neon. There's an old neon light out of something, I can't remember, it might have been out of a heater. Anything like that, it's probably out of. So that's all there, so we could wire that in as well into the switch. Right, so, and the nice thing with this being separate, you could actually put it near the plug. Excuse me guys. So you can put it near the plug, so when you turn it on, the light will go on near the plug, so you know that it's turned on. So that's another option. We'll need a fuse holder. So I've got various ones. These are all pulls from out of different things. So that's a standard 40mm long barrel. That's an external one where the top undoes and it comes off and the fuse is put down and you put that cap on. That's another 40mm one, and that's the internal one where you turn it and that pops out and you take your fuse out. The spring pushes the fuse out. So there's that one, and that one's for, like, if you want something that's really close flush mounted. This one I think is a resettable fuse, but I don't know what it's like. And this is another external, but this is for the 20mm fuses. So that's an external one. So I mean, if you've got a smaller case, something like that would do you. If you want something that's going to be up against the wall and you want to put the fuse at the back, probably one of the flush mounts will do you, or one of the resettables will do you. Oh, you can even put, if you've got the resettable, you can even put it in the top of your case, and if the fuse goes, you can push it and reset it. So there's those are the fuses. The other thing I was going to talk about with the outlets, you could go modern. Now you can pick these up in Aussie. They do these fairly cheap from Aldi's, and I think you pay around about 20 bucks, 15-20 bucks for one of these. These are switched outlets, so these are normal switched power outlets, but they have built-in USB in them, so they have 5 volts at 3.5 amps. And that might be another way to go. So I mean, that's another idea you can go down. I think over in New Zealand here they're a lot dearer. They run at like about 35 bucks or something to buy them from the hardware store. Then as the last thing we need is some wiring. So here's just some old wiring. This come out of something electrical I stripped down. And that's why I say I don't throw a lot of stuff away. I try to hang on to stuff because you never know when you're going to need it. And then of course we have a couple of power cords. These I like because they're moulded. Now this one has the earth on it, which we don't really need the earth. And that's the one without the earth on it. So 6 1/2 doesn't matter which one you want to use. So guys, that's all the bits we've got. So, and we've also got the little strain relief if we want to put that cable on it. And as I said, if you want to have it so you can plug in a PC style connector into the back of it, you'd have to get one of those connectors off the back of a PC power supply, or buy a new one and put it in and screw that onto the case as well. So that's the only other thing you'd need to do if you wanted to do it that way. So that's all our parts. So I just thought I'd show you a selection of bits I've got here. So what I think I'll go through and I'll make my decision on which of these bits I want to keep and which bits I want to use. And once I've done that, we'll start the build. Alright. Okay guys, so I think I've got it all sorted now. That's just my box where I told you I kept all my bits and pieces. So that's got all like the fuses and switches and things like that in there that are pulls from things. So I decided I'm not going to use that or that at this stage, but I mean later on I could change that. So I'm going to go with the box as it is. Now with the cable went in it, I'm going to put the big fuse in there because this one will fit in there quite nicely with the nut on the back of it. So I decided that I put the 2 switches, because these clip into here really nicely. It seems it was a window for some sort of thermal thing that was in this unit when I bought it from one of the e-waste recyclers for a couple of bucks, and I just stripped it down because I like to get bits out of them. So the case, I mean, but for the price of a couple of bucks, I mean, you know, the case with all the other bits that were in it was worthwhile. So all I got to do is get a little bit of something to blank that off, or maybe put another switch in there for something, who knows. So I'm going to use those 2 switches, so that'll be my main power switch, and I might use one for one bulb, and if I decided I want a second bulb I can use the second one. So, but I'll get that to light up when the bulb is in, or the bulb is out, one or the other. So I'm going with the smaller plug, so I can go with the smaller plug on here, and then I'll use this for the one bulb. So if I decide to have a second bulb, I can mount a second one up here. And if I really want to, I could reuse that neon bulb and put it up the top here too. But I think I'll see these lighting up anyway on the front. And then all I think we need to do is just tap a hole in the side here for the cord. And of course there's that there is the clamp for the cable. We want to clamp it in. So that's all good. And there's just a few of the screws that were holding things down. And these are 2 light bulbs I got. They're both incandescents. Now remember, you can only use a normal filamented incandescent bulb or the halogen versions. You cannot use LED and you cannot use the energy saving bulbs. The other thing I had a quick sort of think about, and gear I've pulled apart over times, if you want low wattage bulbs and you don't want to buy them, if you're wrecking a microwave and the bulbs are still good. And these are probably little 15 watts, and they have all the hardware for mounting them inside the microwave. So you could always use one of these, mount it inside the case, so you screw this down inside the case so it's underneath, so you're not exposing anything. And if you wanted to, you could mount them down inside your case, and all you'd see is that top part of the bulb sticking up. Just another idea you might like to try. So I just sort of thinking outside the box of what you could use, stuff you could scrounge around, and they're quite easy to come across. So there's all sorts of things you can do with a microwave. I mean, if the main board's gone in it, but the rest of the gear works, you can always rewind the transformers and make a spot welder out of them. There's another option. So that's what I think I'm going to use. So what I need to do is I need to get my mini tool so I can drill some holes for this, so I can mount this hardware and that in. I'll go and grab that, and then we'll get started on building this thing, shall we? Alright, catch you shortly. Okay, so I'm back. Now, what you may find is while I am doing this, I might mute the volume and put a little bit of background music or something on, because it can get really, really noisy and really annoying. So, just bear with me if I have to do that. So, you can use a battery drill. I have my old Stanley here, but any brand of battery drill, you could use that. Or if you want to be a little bit more precise, you could have something like this, which is basically a Dremel or Dremel. Depends on which part of the world you come in. But this is a rotary toolkit. This is a fuller one. These are really cheap at the hardware. If you want to buy one, you're probably paying around 35 bucks for a cheapie. If you want all these bits and everything in it, you pay a bit more. You're probably paying around about maybe 50, 60 bucks for the whole thing. But they are really, really good. Are really, really good for that sort of thing. They're not much good if you want to do big holes. Unless you want to sort of drill a whole lot of pilot holes around and then knock it through. Or you could drill a hole and then use one of the grinders on it and grind it out. But that's a lot of work. So generally a battery drill with a bigger drill bit will do that for you. So that's why I brought the big drill bit too, because that'll be it's overkill for the size of this, but we're putting that through it, so it needs to be a slightly bigger hole. So I thought that'll drill a bigger hole, and if I need to massage the hole, I've got the Dremel there to do that with, or the rotary tool to do that with. Alright, so I'll move the rest of the stuff out of the way, the bulbs and this box of bits and that, and the cord and that out over to the side out of the way at the moment, and then we can start on working on this and putting the things where we want them. But I think I'll be pretty pleased with around about those sort of locations for them. And as I said, the power, I'm not sure if I'll come off the side or maybe out the back. I'll see how I feel, eh? Alright, so I'll just give this a quick clean up and then we'll get on with it. Okay, so we're ready to go now, guys. So I've got the multi-tool. I've plugged it in and turned it on over the back. So I generally turn them right down. This is before I start to use them. So the way these work is you have a lock pin on them and a collar that loosens, and you can change the internal collars on them depending on the size of the parts you're putting into them. So these little brass collars come out, and they usually come with a pile of different sizes with different bore sizes in them. This is pretty much the standard one that I use. So they do come with a little tool as well that goes across the flat ends of this that tighten it up, because the ends of the little tube in there are cut in across, so that when this screws down it's tapered, so it actually pushes them in and locks them around stuff. So that's just to make sure it's tight and it doesn't slip internally. So what we want to do to start with though is, if you haven't done so, you'll need print a copy of this, be able to, I mean, even just hand draw it from online, pause the video and draw it out so you know how many light bulbs you're having, etc., and the switches. So have a copy of that handy. And then the other thing I like to do is, this is a dark case, so I need to mark where the holes go. So a piece of paper, so this is just a scrap piece from the one we were doing when I was drawing and showing you. So just a scrap piece of paper, and what we'll do is we'll tape it to the top of the box, and then what I can do is I can then work out where the holes are, the main holes, then sit these to where I want them, and then I can put the mounting holes where they need to be on the paper, and then I can drill through the paper into the plastic. Okay, so let me get some tape and let's get on with it. Right, so we've got that all pushed down and taped down. So what I'll do is I'll just use a pen to try and find where these holes are. Now I know there are some holes in it that were there before. So I thought, well, if the holes are there, we might as well use them. So if you rub around them enough with your finger, you'll have enough dirt and that on your finger to actually put an outline of where the hole is. Or you can look underneath. So this other one is over here. And as you see, I'm just rubbing around, and you can't really see it from here, but it just starts to show up where the hole is. So that's just dots around the outside of where the holes are. Now you might be able to see it a little bit better, but what I'll do is I'll lift it up to the camera for you. Now you see the rub marks where the holes are? So that's just showing me where they are. The other little screw holes I'm not too worried about, because I can fill those in with something later on. So now what I want to do is I'll get my PowerPoint. Now I'm using this one. And the nice thing with reusing these holes, if I want to change it later on, I'm not making more holes in the case. So with this, I'll put this down. Now I want to look at, so how do I want this to work? So what I want to do is I want the switches towards me. So the PowerPoint I want on this side, because I want whatever I'm testing to be on that side, on the right of me. So the light bulb will be to my left. So what I do is I see where the hole is, and I can make sure that I can get the screws into this without being too much of a pain. So I may have to rotate that a little bit. And so that just means that the power socket will sit out like that. I could turn it right round if I like and do it that way. So when I plug something in, it faces that way, or down. You know, it depends on, if you've got to make the holes, you set it wherever you like. But what I'm thinking is I'll do it sideways like that. So therefore, if I plug something in, I plug it into the side of it, and the cord will go out. So I'll put that one down there. And so why we do this is then we get a pen or a pencil or a fine tip marker, go down inside the hole and mark those two pins, and there we have them there. That's telling us where we've got to drill the holes to bolt this on. So we do that, and we can do the same with the light bulb as well. So what I want to do is I want to have as much room up here so I can stick a second one in if I need to. So I've just got to be careful where these holes, screw holes, go through, that I'm not too close to where the cable comes through. So I mean, that would be fine there. But I mean, it's up to you. You can, if you don't have these holes and you want to make new holes, I mean, I could have done it over here, I suppose, if I wanted to. But I'm just getting a bit close to the side of this case and that, and I thought, well, over that way, that'll do me. You know, yeah, I mean, yeah. No, I think that'll do. I've made my decisions. That's what I'm doing. So, take these off now. Don't lose the screw out the front of that. We'll move those out the way. So now what we're going to do is we'll leave that for later. get the Dremel, and so we only need small holes in them. So what I'm going to do is I'm going to use a small piloting bit. And as you can see, it when it burns through, the plastic gets hot and it melts, so you can pick all this off later on. But we have our holes through there, so now we can take the paper off. So now you can see there's the holes that I've done. That's our big hole, that's our small hole, so that's all good. So now what we need to do is make sure we have the holes the right size that we need. So we need to change this bit and put a drill bit in now, so we can actually drill the holes a little bit bigger. And just remember, guys, these are messy tools. And also, remember, these are dangerous. So when it's turning off and it's still spinning, don't go to grab this. You'll do yourself damage, okay? But I usually find it around about between 3 and 4 is fine for doing plastics and things like that. It doesn't get too hot to melt it. Alright, so what I'll do is I'll just move all this stuff off and give it a bit of a clean and a wipe down, and no guys, I'm not throwing it on the floor. It is going into my hand, alright? Okay, so what I've done is I've just unplugged this for now. We'll move this out the way because we'll need it a little bit later on when we go to put the cable and that in, but for now I'll just move it out of the way so it's not in my way. Now we have our case. Now, as I said, these fitted in here really nice, these clip-in PC style switches. So the only thing you need to do is just work out the polarity on the switches for the neon to work. So one way it'll work when it's on, one way it won't work when it's off, and we just got to work out which side goes where to make it switch. So, and of course I'm not tightening this up, the fuse up, until I have the wiring done in here. Those are a little bit small. Those are a little bit small. So I'll have to get a couple of slightly bigger bolts for that. So hang on for a sec. That's the other thing I do, is when I strip things down, I hang on to a lot of the different types of screws. You never know when you're going to need something like this. And you might need something weird and wonderful when you don't have it. So find something that's a little small. That's big enough, and that'll go down inside there too. So 2 of those. So see, and there's 2 of those, and that's what I say. That's why I always go through when I strip stuff down, old monitors and TVs and things like that. That's where a lot of these sort of heavy bolts and screws and that come from. A lot of that stuff I hang on to them. These are all our different types of cases and things like that. You just never know when you're going to need a weird size 1 or 2 bolts, saddles and all sorts of things from different things. Clamps, these are stainless steel, so that's why I hang on to those. So I mean, all that sort of stuff, and I just keep it in a jar, a lid on it, put it in the shelf out the way, and you just never know when you're going to need one. That's how that's going to look for now, so I'm quite happy with that. I mean, it's up to you how you want yours to set up and that. So that's pretty good. So that's the base, and that base screws on. I have the screws for that, so that goes in under there, and it has like little rubber feet on the bottom of it to hold it up. So that would be there. So now I just got to decide, do I want the power cable on this side or over the back here? And I'm just thinking, if it comes out of the back, I'm not having to worry about it getting it, so I can actually have it up against something, and this comes out over here, so it can be up in a corner. I mean, I could also bring it out the side here as well, where the fuse is. I could take the fuse out and put the fuse down here and have the cord out here, so the cord comes out, plugs in, so this can go up into a corner. So, but I mean, the bulb's going to be in there, and if we put a bulb in, you got to watch to see how close you are to a wall anyway. So so I may just put it in the back, I think, because by the time the cord comes out and bends around, it's going to be enough to hold that away from the wall. So I think that'll be fine. I think we'll put the cord in the back. You talked me into it. So what we will do is pop the back off. No, there is no lip on that, so that is good. So now what we want to do is to work out whereabouts we want to put it. So that's the pipe. That's the pilot hole I've put in it. So I've just got to make sure I can make the hole the size for this to go in. So that's all I've got to do. So I now know I've got to make it a little bit bigger. Or I could pop the cable in and cable tie it on both sides. Or put a grommet in there to hold it all in. So I mean, either way, or a bit of hot glue or something like that. So, but I mean, if I put a cable tie on this side, it's not going to pull out, and if I put one on this side, it's not going to pull in. So yeah, I don't know. Yeah, do I want to go with mucking around with that? I don't know. I can change it later on. Alright, so yeah, I just chucked all the rubbish in there. Right, so what I'll do is I'll grab the cable. Wait, cable. So we'll see. I mean, that just fits in. It's a fraction big for it, so it just fits in there. Which I think, you know, if this goes on here and against a wall or something, that's going to be fine. And so it can go either way too. You can have it either way. So, and I think a cable tie around there and one on the inside, and it's not going to make a difference. So I think that's going to be fine. Right, so what I'll do is I will pop this up and I will unscrew these parts out of here, put my glasses on and get the diagram, and let's put this thing together, shall we? Right, so now we're ready. So I'll just turn my iron on. So what we'll do is I've pulled all the connectors off the ends of the double one, which I'm going to use. So I'll use one for now, and I may look at putting a second bulb holder on. And I might, as I say, I've got a couple of old microwaves I've got to strip now anyway that I've been given. So I might put one of those little 30 watt ones in for one, and then the other one I'll put in for 70 watt or 100 watts or something like that. Probably 100 watts. So, but yeah, so, or I could put another, just a standard bulb in here, and I can get whatever, you know, little pygmy 20 watt, 15 watt pygmies, all the way up to another 70 watt if I like, and I can just switch them on and off. So I've done that one. That one will need to desolder, but what I'm going to do is push on connectors onto here. This is the way they used to do it. They used to solder everything on because it was saving money. But if the switch ever packs up, there is nothing worse than trying to get it out when it's soldered in. So I bought, quite a while ago, I actually bought a toolkit, and it came with a pair of these crimps. These are ratcheting crimps, and I bought a pile of different connectors. Most of these are automotive style. So these are brass ones. These are what they call bullet connectors and sockets. And you can buy all this stuff online through AliExpress and that. And this is the other one. Now I have this tool because I had to rewire me. I have a 76 CF Bedford cab chassis, so truck. So I had to redo the wiring in it. So that's why I bought this. So, but it's also good for doing electrical work as well. So, and this has all the female and male bayonets. It has the earthing loops, it has joinets, and it comes with all the different size covers and heat shrinks and that. So I'll use these. Alright, so I just thought I'd show you that. So that's the kit I'm going to use. I can use those there when I do this. So I'll show you how to do that when I do it. I'll just move this up out the way. So what I need to do is to desolder the wire off this. And so this switch is 250 volts, 15 amps AC. So this is going to be more than enough what we're going to use, because our power outlet is only 10 amps. So right, as you saw there, sometimes when you're desoldering stuff, if it's old solder, you sometimes have to add new solder to your iron and adding it to the old solder to get it to release. So, but this one had a piece of wire wrapped around it, and I just wanted to get it out. So that's why I bent it. That's why I had to bend it up slightly, and then heat it up with the iron and work it around so I could get it out the hole, and then banging it down, it just throws all the solder off. So as you can see, all the solder's come off of those now. So what I'll do is I'll just clean all this off, and then we'll carry on. Well guys, that was a bit of a marathon, wasn't it? Sorry it's going to have to be 2 parts. But I'm hoping you're going to hang in there, and we're going to finish this off on the next part. And you're going to get some good benefits out of this piece of kit. Alright, so I will see you shortly. Hang in there. Ciao.